Hello, everyone. Thanks for coming. My name is Albert Chon. I'm the co-founder and CTO of Injective Labs. Injective Labs is one of the core contributors to Injective, which is a layer 1 blockchain. And today I'll be talking about Injective and building the next generation of DeFi. So Injective on a high level is a blockchain built for finance. Our focus is on powering the next generation of DeFi applications and providing a lot of powerful advanced DeFi infrastructure for builders. First, I'll talk a little bit about the Injective ecosystem. Injective is one of the fastest growing ecosystems in all of Cosmos. We have numerous projects in the Cosmos ecosystem, in the general crypto ecosystem building with us or partnered with us. And yeah, lots of opportunity. Before I talk a bit about Injective, I'll first introduce the concept and mainly the power of self-sovereign, interoperable, application-specific blockchains. So I know this is ETH Belgrade. It's mainly an Ethereum-focused conference, so some of these terms may be not that familiar to you. But the general idea is that if you have your own blockchain with its own validator set, there's many different kinds of applications that are much more powerful to build rather than just being a dApp written in a Solidity contract on Ethereum. So what are some of the benefits of building your application in this way? The biggest one is performance. And the first benefit you get out of the box is that your application code can run natively. So you have native code versus virtual machine bytecode, which is, of course, interpreted on a virtual machine and is less performant. There are also many constraints into building your contract in a virtual machine. Namely, you are restricted by all of the constraints of the EVM, as an example. So many of you guys may be familiar. Your contracts have to be less than 24 kilobytes in order to be deployed, meaning you have to structure these in an awkward way. You also just have limitations in what you can do. Whether it's just having a smaller set of opcodes to work with, or having to learn all of the idiosyncrasies of the EVM, or write your code in assembly just to get a little bit of more gas optimization. And if you think more broadly about how the next generation and the most advanced financial tools and products will be built, it's a very clumsy way to have to do this. You want to have the full feature set of a modern programming language, for example, like Golang. And there are many benefits to doing this, and one of the biggest ones, performance-wise for Injective, is parallel execution. So because your code runs natively, and your only requirement is essentially to make sure that your code eventually is representing a finite deterministic state machine. So you can use things like parallelism, Go routines, channels, all of your favorite programming constructs and data structures to design your application. And it's a much more flexible way than being constrained by, let's say, a mapping of bytes 32 to a struct, and then not being even able to iterate through the keys, like you might have to do in Solidity. So generally, developers, I think, and coming from the Ethereum development ecosystem myself, they waste a ton of time in having to be in such a constrained environment. Another big benefit of building on an application-specific chain is the control you get over consensus. One of the biggest benefits here for us are 1-second block times. So Injective is one of the fastest blockchains in the world today, as well as instant finality. And instant finality is a benefit that cannot be underscored enough. On Ethereum right now, you must wait 64 blocks or 2 epochs for finality, about 12 minutes. And on other chains like Polygon, you might have occasionally 160 blocks of a reorg. So if you think about advanced financial applications, let's say in exchange, lending, market making, that's simply a no-go, right? You cannot think that you place a trade only to find out minutes later after the market's moved that actually you haven't. So instant finality and fast finality are incredible, powerfully important principles. The next point is flexibility. So because you have full control over your state machine, you can do many things that you otherwise wouldn't, even compared to other smart contract platforms. An example of which is that Injective has Ethereum-compatible accounts. This means you can use your favorite wallets, like MetaMask, Trezor, etc., Ledger, and just have it work out of the box. You don't even have to switch the network. It can just work. Whereas, suppose even if you were to build on Solana, you're constrained by what Solana will allow you to, right? You have to use their Phantom wallet. Your users will have to then switch wallets if they decide to bridge over. It's just a generally bad experience. One other very powerful primitive that Injective offers is the ability to execute code in the beginning and the end of each block. So for those of you who are coming from Ethereum, state transitions occur through transactions, which are, of course, signed by users and then broadcast to a network. And then ultimately, maybe some state in your smart contract will change, let's say, your balance. However, on Injective and other Cosmos chains, you have the ability to execute code in the beginning of the end of each block. And this is a very powerful capability where you can do things like, for example, Injective uses this for order matching, where orders that come in as transactions get queued up and then are matched then at the end of the block. And we use this also in some very interesting ways, which I'll talk about in the next slide. And finally, the last point is application control over consensus, particularly with ABCI++. So for those of you who haven't heard about the ABCI stands for the Application Blockchain Interface, and the plus denotes like the next iteration of ABCI. And there are a few things that you can do that I'll highlight. One of them is an app-defined mempool or an app-specific mempool. So of course, mempools generally are a set of pending transactions essentially that nodes have, but they aren't exposed to the application. Like for example, your smart contract on Ethereum can't look at the mempool, right? It's just not up to you to peek into. However, with ABCI++, you have the ability to, for example, define your own validity rules, or if you want to reorganize transactions within that block, you can. And protocols can use this in interesting and powerful ways. One example I'll give you is prioritizing Oracle transactions. Of course, we know oracles are very important, and there's a lot of different attacks like front running that can occur. Your application, your blockchain can decide, hey, I see these Oracle transactions come in. I want to put them at the front of the block so that all transactions afterwards will use the latest Oracle prices. You simply can't do that on Ethereum, which is why you have things like flashbots and MEV, and of course, many vulnerabilities or deadweight loss that you have to account for. Another benefit of ABCI++ or feature that it offers you is the ability for validators to perform work or consensus to perform work so that your network doesn't have to. One example of this is, suppose you want to have your validators themselves be the oracles, or suppose you want to encrypt your transaction using threshold cryptography and have your validators decrypt them with multi-party computation so you can have private transactions. You can make your validators do work as a part of consensus to actually do this, whereas you otherwise wouldn't. And the final piece is on interoperability. So Injective supports IBC. It's an IBC-compatible chain. And IBC, or the Inter-Blockchain Communication Standard, is one of the most battle-tested standards for not only token bridging, but all sorts of arbitrary data, arbitrary message passing, and is a very secure way to allow blockchains to interoperate. And this isn't specific to just chains like Injective or chains in Cosmos. Actually, this is already being used by Polkadot and other chains that can support this Litecoin proof system. And the final piece is on modular design. So as a blockchain community, we can not have to reinvent the wheel, especially in the Cosmos ecosystem, and reuse code and more easily agree on a set of standards to design applications around. So I'll talk a little bit more about some of the key primitives on Injective and some of the DeFi infrastructure that Injective offers for developers. The biggest one is the on-chain limit order book and limit order book exchange. So Injective has a fully decentralized on-chain exchange, order book-based exchange for spot, perps, expiry futures, and also binary options. And this is, the matching engine is on-chain, everything is on-chain. It's one of the most advanced and most highly performant DEXs in the world today. Also bridging. Obviously, IBC, as I mentioned, is one such bridge, but Injective also supports a variety of bridges, including our own native Ethereum bridge, where you can, in just 5 minutes, deposit tokens into a smart contract, have them appear on Injective, and be used in your application, as well as support for many other bridging protocols like Axelar, Wormhole, and such. Oracles. So many DeFi protocols rely on oracles, and oracles, of course, have a wide range of security and trust assumptions. And Injective takes an unopinionated view and tries to support as many oracles as possible, ranging from Pyth to Band, and even coming soon Chainlink, as well as the Coinbase Oracle and other custom-provided oracles that you yourself can choose to provide. Next is Injective Smart Contract Platform, which is offered by Cosmosm, or WebAssembly essentially on Cosmos. And this is one of the most advanced smart contracting platforms in the industry today. You can write your code in any language. The most popular one is Rust. Have it deployed on Injective, and not only interoperate with other contracts on the chain, but also with the native modules or native functionality provided. So you can do things like, let's say, enter into a 10x long BTC perp position, pair it with, let's say, 2x short ETH position, wrap it in your smart contract, and offer it as a structured product if you still wanted to. It's highly interoperable, and yeah, the developer experience, since you're writing your contracts in, let's say, Rust or a general high-level programming language, it's very easy to do. And finally, one of the most interesting pieces that Injective offers is the ability for automated smart contract execution. Now, this is maybe a little unfamiliar for you guys since we created it, but the general idea is that you as a developer have the ability to have your smart contract be executed by the chain itself, even up to every single block. So of course, you prepay your gas and such for this, but now this opens up a whole new field of possibilities and reduces a lot of the other complexities that you would have to otherwise include. So on the Ethereum side, you may be familiar with things like keepers, which are essentially bots that run functionality that any smart contract or a smart contract allows anyone to call. And the problem has always been, how do you incentivize these keepers or these off-chain actors to actually execute this, be the white knight? And the answer is, of course, you have to pay them in some way. Maybe it's you get some liquidation bonus or some other mechanism. And that's essentially kind of like deadweight loss to the protocol. And now you no longer have this if your application could automatically run like that logic, automatically run, let's say, whatever bookkeeping or risk management things that it would have to do. And just to illustrate a good example of this, we try to reimagine automated market making. So on the left side, you see the constant product AMM formula, X times Y equals K, that everyone knows and loves. One great innovation of crypto by Uniswap. And we all know the common pitfalls of this, right? Namely, impermanent loss. Most LPs lose money by providing into an LP pool. And that's generally because you are shorting volatility, right? You make money through transaction fees or trading fees as they arrive, or as they get traded against the pool. And of course, crypto is very, very volatile, and that's usually not a good thing not a good view to express. So we had the idea of what if you could have high-frequency trading or a high-frequency automated market maker on a limit order book, and that might at first seem to be colliding concepts, like an automated market maker on a limit order book, but actually it's not. If you consider the automated part to be the fact that this market making strategy can be on the chain itself and executed even up to every single block, right? Then you can have a dynamic strategy that will take in real-time data from the chain, let's say oracle prices, volatility, the order flow that you get in real time, and respond and market make appropriately. And the result is you can have a dramatically more capital efficient and also dynamic strategy that can make money. Next point is interoperability. So interoperability is at our core. We interoperate with Ethereum, with Arbitrum, with Polygon, and many chains in the world out there. So for the end user, you have a very seamless experience where you can simply deposit your tokens, have them show up minutes later, and be fully interoperable. Of course, as mentioned, you can still use MetaMask, you can still use your favorite wallets, and provide generally a really good user and developer experience. Yeah, finally, I'll talk a little bit about the ecosystem venture group. So Injective has a $150 million venture group for builders and projects to come all the way from the idea phase to the launch phase and beyond. As I mentioned, Injective is one of the fastest growing ecosystems. So definitely, if you're interested in DeFi and building the next generation of finance, come meet us, come talk to us. We'll also be having a happy hour tomorrow at the hackathon venue from 2 to 5 p.m. If you want free food, free drinks, come by and come meet us. All right. Thanks for listening. You can follow us on Twitter @Injective. And yeah.